Welcome to the Fractions Comparison Basic lesson. We are going to build out a math program that's going to allow your users to be able to compare fractions based upon a certain range of random numbers. This is the basic version. There's going to be some more advanced versions out there where we can select the difficulty, and they will probably be a little bit different than what you see here. This is going to comprise of one major script on this entire program right here, which is going to be on the object called CalcuCat. And CalcuCat is a sprite, and I also call it an object. So if I ever call an object, just know that object and sprite mean basically the same exact thing. And then over here we have some other sprites or objects, if you will, and most of these aren't going to have any code inside them. If you're new to Scratch, let me quickly explain the layout right here. So this will be our screen window where all the output takes place. This is where you see all the action. If you're making a video game, you'd be able to look up here and test out your program, see how it's interacting. And over here down at the bottom we have some different icons. We have the stage icon. The stage icon is the background. The stage cannot move. It can't really do much of anything other than host a backdrop, and the backdrop will just be a graphic image. I just picked one of these from the Scratch library. I have a video that goes through all the details of Scratch, so I'll let you go check that out. So I'm going to quickly run it down just in case you don't have time to watch it or you just need a quick refresher. Over here are our sprites, as I was telling you just a second ago. One thing about the stage before I leave is that this is a great place to host code if you want a central location for some programming processes that are going to make decisions that will affect other sprites, but you don't want them in a sprite because the sprite might get destroyed or something else like that. So with that said, stage is a good place to host centralized objects. And let's see what else. Oh, the stage, it has a limited set of programming blocks. You notice the motion category right here doesn't have any blocks inside of it because the stage can't move. And as you probably guessed, these categories up here host different programming blocks for Scratch, and they allow you to do some pretty cool stuff. Okay, and they're very much related to the actual topics. And I'll explain this as we go along. And again, these are the sprites. And let's see what else. So what's going to happen in this program is when we run it, we're going to ask the user to compare these two fractions. And what I've done here is I have the variable outputs above and below the bars as a numerator and denominator. If you wanted to, you could actually right click and choose large readout and do the same thing with that. So that way it looks a little bit more like a real fraction. And you can change the size of these as well. I left the output as normal readout for right now because I want you, as you create it, to be able to quickly locate and identify where the numerator A, denominator A, numerator B, and denominator B are located. Okay, so that way you don't get confused. So right here, the cat wants to know which fraction is larger, or which is larger, fraction A, fraction B, or are they equal? So I'm just going to say that 10 over 3 is larger, so I'm going to click on that one, and the cat tells me I'm correct. That is fantastic. And then it asks me if I would like to play again. So I'm going to put yes, Y for yes. It says round 2. And then it asks me if these fractions, which one's larger or smaller. I'm going to pick the equal symbol. And it tells me I'm incorrect because they are not equal. So again, you'll be able to go through, and I'm going to choose no, not to replay the game. Then the cat gives you a score. Okay, there's ways to make this repeat itself more and more, and I'll explain that as we go through the code. What you want to do now is go find your file called Fractions Comparison Intro. Your teacher may have given it to you. If you haven't got a copy of it, you can get it from the website if you subscribe to this channel, and I will give you a access link to my Google Drive so you can go out there and download all of our files for these lessons. There should be some additional information out there such as rubrics and maybe some quizzes if I get the time to make those things. Hopefully I do, since I just said that and I don't want to embarrass myself. All right, so let's go ahead and get to work. And quick reminder, make sure you subscribe so that way you can get access to all the files. All right, so our program is mainly going to focus around the sprite called CalcuCat right here. Okay, I'm surprised I said that correct. CalcuCat. Okay, so CalcuCat is going to do all the calculations for us when we program this. We're going to start off by going to our events category here, and we're going to get a green hat tool and drag it over here into the scripting area. And next we want to get some variables. So we're going to go here to data, and we'll have to click right here to make some variables. We're going to make 3 variables, and we're going to go ahead and do this to start off with. We're going to create one called play again, make another variable called round, and then finally we're going to create a third variable called score. And I shouldn't say final. Oh, before I close this out, I should mention something here. Okay, we type our variable name in right here. Down below there's 2 options. We have for all sprites. These are a global variable. That means everything can access the information that this variable score stores. Okay, so if the A block sprite wanted to access the information inside the score variable, it would be able to do so. If we choose for this sprite only, that means only CalcuCat can access the information within that variable. When you get into more advanced programming with Java, C#, or Python, you'll find that you want to create what we call local variables or instance variables, such as for this sprite only. That'll be your main go-to type of sprite whenever you make programs. However, since we're just learning, it's really easy just to make global variables for all sprites, so that way it's just kind of nice and simple and very approachable from all different angles. Okay, so make sure we click on OK. Now we got our 3 variables right here. We're going to drag over our set block, and I'm going to right click, choose duplicate, and choose duplicate one more time. And I should have 3. I'm going to change the drop down menu to play again, round, and score. Play again, I'm going to go ahead and set this to Y, because the user will enter in information that gets stored in this variable, and we're going to go ahead and populate it with some information, so that way the program can make a decision early off with what to do with this, or what to do with the play again variable. And then over here is round. We're going to start that at 0, and score, we're going to start that at 0 as well. Over here underneath the control tab, we want to choose the repeat until block, and we're going to whoa, I meant to go to operators. We're going to get this Boolean block called the equals block. And the equals block is going to check to see if something is equal to each other. And we want to see if our variables play again is equal to n, capital N. That's going to be representing the word no. If you remember when I ran the program, I typed in no at the end, so I didn't play anymore. And this is what gets checked to see if the user wants to quit or not. So when the user enters in the information no, it gets stored into the play again. And when it equals this, the program will stop executing all the code. So the entire program is essentially going to be running off of this repeat until block right here. All right, next we're going to go ahead and start building out our repeat until block. And let's go to events, and we're going to get a piece of code here called broadcast message and wait. This is a broadcast block, and what it's going to do is it's going to send a message that we'll design to another function, and that other function will perform some sort of code based upon whatever we put inside of it. And this block right here, when it sends the message, it'll wait for the other code to perform its action, and then it's just going to wait until it's done. And once it's done, then it will move forward and start processing all the code below. So what we're going to do with this one, we're going to create a new message. We're going to call it set variables. Did I spell that right? Oh, I sure didn't, did I? It's hard to see on my screen here. And it's kind of embarrassing now I think about it. Okay, so we have set variables. I'm going to go ahead and click on OK. And if I misspell a word, let me know, and I'll send you a sprite sheet with some cool sprites on it just to say sorry. Over here we have a when I receive message. We'll click on set variables, and we want to change some blocks here. Or excuse me, we want to use the change block, and we're going to use the change. We're going to change the variable called round, and we're going to change it by 1. So that way the round variable, it's going to increase by 1 every time this message is received right here. Okay, so once we receive this message, we're going to change round by a +1. If we wanted to, we could also put in a -1. Below that, we're going to put in some set variable blocks, and we're going to need 4 of those. So let's go ahead and duplicate it and get 4 built out right there. And we want to change the Oh, we need a new variable, don't we? Okay, so we're going to create a new variable called player answer. So we have a new variable called player answer, and we'll go ahead and click on OK. And we'll change the first one, set player answer to. We're going to leave it at 0. Next, we want to create another variable called output A. That will be explained here in a second. And we're going to create another variable called output B. And then we want to create a final variable called valid entries. One of the advantages of having all of our variables set over here in a separate function is it helps make this code smaller, which you'll see it's going to get very large. It also allows us to have some control over where we put information. Let's choose player answer. It's going to be set to, well, I have that. We want output A, output B, and last but not least, valid entries. Come on, there you are. All right, so valid entries right there. Next, we're going to go back over here into our main block, which is underneath the green flag, and we want to find the say block underneath looks. So go ahead and find say, and we want the say block that has 42 seconds over here on the right-hand side of the block. You could use this one, however, this one's better because it's going to keep the message on the screen for just a little bit of time. So I'm going to go ahead and put it right there. And we want to tell the user what round it is when we run the program. So we want to get a operator block called the join, and it's right there. And we're going to type inside here where it says hello, we're going to type in the word round and hit space so there's a little bit of space. And over here on the right hand side where world shows up, we're going to put a variable in there called round. So what's going to happen is whenever the computer runs this, the cat's going to tell the user, we're just going to drag it right there, the round number. I'll go ahead and run it and you can check it out. So it says round 1, okay, round 2, round 3, round 4. Can you guess why the number keeps increasing? If you guessed that it keeps increasing because it's in the repeat until block, you are correct, okay? So it's going to keep repeating that until play again equals N for no. And if I wanted to, I could drag this block over here and find play again. And I'm going to change that to a capital N. When I double click on this code, it'll actually set this variable play again to N. And you can see it happen right up here in the top left hand side. So I double click it, changes that to N, and you'll notice the program stops. Okay, so that's what's taking place with this repeat until block right here. If you want to, go ahead and test that out and see what happens. I'm going to drag it off because we don't need any more, and we're going to get another repeat until block. This is called nesting when we start putting these looping blocks or conditional blocks inside each other, or control blocks if you will. I'm sorry, I'm used to teaching Java. I'm a computer science teacher, so sometimes I get the Scratch terms and Java terms and Unity terms all confused. So underneath the say block, we're going to put the repeat until, and we want to use another operator, which is the equal one. We're going to put it right there. And we want to get the variable called valid entries. We're going to put it right there. And we're going to put in the word true. Okay, so when valid entries equals true, we're going to allow some code inside here to execute. And I forgot to do something over here, and this is really important, okay? So if you could, make sure you stop what you're doing and make these changes. In output A and output B, we need to put in this symbol right here. N-A-N, actually it should be N, capital N, lowercase a, capital N, lowercase a, capital N. What that stands for, it means not a number. And that says if we get into a situation where we're dividing but with a 0, we want the computer to know that it's not a number, and that way it'll go back and keep looking for another random number, so that way we don't get into a situation where there's some sort of fraction that has a 0 at the denominator, okay? So this helps make sure the program keeps running, with a good function. Down here on valid entries, let's go ahead and set that to false. I know I put 0 before. That was my fault. I forgot to type in false there. I just get so excited when I make these programs, I sometimes forget to look at my notes. So we're going to set valid entries to false, okay? And this right here is going to keep repeating this information until it's true. Let's look at inside here and see what's happening. As long as valid entries is false, that means it's not true. The code inside of here will keep repeating itself. And this is what's going to create all of our random numbers for the program when we start executing it and allowing our users to go play the game. Also, so you know, all these variables are going to show up over here on the left-hand side in your screen. Don't worry about that. We'll clean all this up once we get to a point where we're ready to start making the output look like an actual program. So inside here, let's go ahead and get some set variables. We're going to need 6 of these. So I'm going to right-click, choose duplicate. Got 4, and there we go. We have 6. And we want to come over here and change this one to numerator A, which I forgot to make. So let's go over here to make a variable. We're going to call this one, numerator A. Go ahead and click on OK. Then we'll have another one called numerator B. We want to have denominator B, denominator A. Well, we'll have a B too. Denominator A. I'll just copy and paste that term right there. And denominator B. So right here, we're going to change that to numerator A. Whoops, I meant to choose numerator A. There it is. Numerator B, denominator A, denominator B. And then we want output A and output B. Now these blocks are going to go inside here, but I'm going to build them outside of the repeat until. It just makes it a little bit easier to move everything in there at one time. We want to get a operator block that's going to be the random number generator. And that's going to be pick random 1 through 10. You have your low range value and your high range value. And you'll stick it right over here inside the data entry portion of the set block. And we want to just go ahead and select it for 1 to 10. As you get more comfortable with the program or better with fractions, you can increase or decrease these ranges to whatever you want. I'm going to go ahead and right click and choose duplicate and put one right there. One more right there and one right there. Okay, so we're just going to stick with the range of 1 to 10. If you wanted to, you could put in, say, -10 and go up to, say, 22. Whichever kind of number you wanted, you could put it inside there. We're just going to keep it real simple and generic and just stick with 1 to 10. Our output's going to be a little bit different. Our output is going to require some division, because what we want to do with the output A and output B is we want to go ahead and divide the fractions that are coming from the numerator and denominator, and we're going to get it turned into a actual decimal value, because computers work with what we call floating points, or rational numbers, or irrational numbers in some cases. So what we want to do is we want to get changed into a decimal value by dividing our fraction, and there we can easily compare output A to output B. So I'm going to go ahead and put my division block inside the output A and put one inside output B. And then we want to go over here to data and choose numerator A is going to be divided by denominator A. And the same thing for output B, numerator B, and denominator B. Whoa, if that happens to you, make sure you catch it. Go ahead and pull your block out, and if you need to, go ahead and just click and drag and put them together outside. Also, here's a little piece of information. If you double click on the block, it's going to give you an output. Right here, since we don't have any data values in here, it's giving me NaN for not a number, which comes from right over here. No, excuse me, it doesn't come from over there. It's coming from the fact that there are no values inside here, okay? And we went ahead and set these to not a number just to make sure. So you can see that Scratch is automatically generating that output whenever the fractions have no values. So let's go ahead and put it right there, and we'll drop it inside our repeat until. Now we want to nest some more conditional blocks. These get all the random numbers, divides the numerator and denominator to give you the output A and output B, so you know the values of the fractions and you can compare them, which we'll do here in a second. Below that, we want to make some decisions to catch any sort of programming errors by Scratch. So we just want to make sure we don't get any sort of weird data. We probably could skip this, but if you had an error in your program, you would wish you had it. We're going to use these if-else blocks, and how these work is that the first Boolean section up here at the top will look at a condition. It'll say if it's true, then it's going to come down to this little area here where we'll have some blocks inside of it, such as, well, let's get a say. It's going to go ahead and say this, and if that's false, it's going to go down to the else section, and here's it's going to perform some sort of other code. We can take another if-else block, which is what we're going to do. We're going to put it right there in the nested else section, so that way if this is false, whatever condition that is, we come down to this else section, and inside here we have another set of conditions we have to check to see what kind of decision we're going to make in our program. And let's go ahead and get that put together a little bit. We're going to put our say right here, and I forgot what I was doing. Let's go ahead and get a set block, which we'll put that right there. We're going to change this to valid entries, and we're going to change that to true. Make sure it's spelled exactly the same as we check right up here. If you put a capital T in for true and you type in a lowercase t, it's going to say it has two different values. So right here I type in a lowercase true, all lowercase. Down here is all lowercase true as well. You probably heard the term case sensitive. That is what's happening right here. The computer is case sensitive, and it sees a capital T and a lowercase t as two different letters. Inside our first condition here, we're going to look for something. We're going to go ahead and get an OR block, and let's put it right inside there. And while we're doing this, you'll notice I put the blocks together in a lot of different ways. I do that just so you can see some versatility on how you program, so that way you don't get locked into one fashion. Because Scratch is very, very, very good. However, sometimes putting these blocks together, they start getting kind of large and it gets kind of awkward at certain points in time. We want two of these, and we're going to put the first one on the left-hand side of the OR, and then the second one on the right-hand side of the OR. And inside of that, we want to check our output A. We'll put it right there. And we're going to check to see if it goes to infinity. Okay, and this is something that will be generated by Scratch also. Scratch could give you an output that says the division goes to infinity. So we want to look for that. We want to make sure we don't have a value that goes to infinity. And I'm going to choose duplicate on output A and put it right there. And we also want to check to make sure that we don't have not a number getting put inside there. So that way we know that there's an actual true output that we can calculate and compare. So in other words, we're looking for programming errors within Scratch, which is possible. And we're going to put a message right here, okay? And we're going to say DA, denominator A, is a 0, okay? Net will get outputted to you if denominator A is a 0. That way you know there is an error in your program. It's only there as a warning signal to you to let you know what's taking place. When we get into Java and C#, you'll notice that we use these kind of like little flag or console outputs, as we call them, to let you know if something's wrong with your code. So that's all we're doing right here, just getting you used to actually having some sort of output from the computer to let you know there's an error. And I'm going to double click, choose Control C, then come down here in the second say, hit Control V, and I'm going to put DB, and DB is short for denominator B, and I'm going to go over here into the OR Boolean, right click, choose duplicate, and it gives me a perfect copy of what was inside this if section. I'm going to drag it down here into this nested if section. Sorry about that. Been drinking a lot of coffee today. And down here, we've already tested output A, and whoa, yeah, output A. That's right, I want output A. Down here, I want to test output B. Let's go ahead and choose output B. So now we have output B, and we're testing to see if output B has infinity or not a number. And that way, we'll signal to the user that the denominator B is also a 0. Next, I'm going to take this and drag it into my nested repeat until block. So that way I kind of get out of the way and we can start seeing what's going on here. Whenever we can go ahead and run it and see what happens, right? So round one, that came from right over here when we set the values. You'll notice output A and output B are calculating a lot of different random numbers. The reason it's doing that is because, and if yours is doing this, this is great. This is what you want. And you can actually stop the program and see that there's some different output happening right here. Okay, so that's perfectly normal. The computer's just going through and testing this and testing it and testing it because we haven't got to the next section where we actually slow the program down to allow the user to make a decision. And we'll get to that right now. So right now, all that's taking place, we're repeating the random number generation, calculating the output A and B so we can figure out which one's larger, smaller, or equal. Over here in this nested if-else section, whoa, drag that back, we are just making sure that we actually have real numbers or some sort of valid output for A and B. So this is kind of like a little security check. I can put a comment right there if you want. And see how it attaches like that? Let's just go ahead and put a comment. Let's call it security check for valid inputs in DA and DB. Okay? That will help you out in the future. Because if you come back to this program in a week, you're like, oh my gosh, what is all this stuff? Having these little comments will help you out significantly. Next, we are going to get some more control blocks. And we want to get an if-else. We're actually going to use two of these. I'm going to go ahead and nest them right there. And I believe they go, let's see, they go inside of the main repeat until. That's kind of hard to do right there. I only know because I took notes when I made this program a couple years ago. So what I do with my nested if else, I'm putting it right there. And I know that I want it in that repeat until because once I have valid input coming into my denominator and denominators, or my numerator and denominators, that way once I know the input's good, from the valid number from the number generation, I can come down here to these conditions to start figuring out what is going to be the correct answer. We want to get a operator block, and we want to get the greater than symbol block, and we want to get data, and let's choose output A, and we want to choose output B. And we're saying if output A is larger than output B, then we are going to set our answer, or excuse me, correct answer. Oh, I didn't make that. Let's go ahead and stop our program. So we need to make a variable called correct answer. Let's make it all one word. So correct answer for all sprites, and we're going to set the correct answer to A. Next, we want to right click, duplicate, go ahead and put it right there, and you can switch these up. We're going to see if output B is larger than output A, and if that's true, I'm going to duplicate this code and put it right there. We're going to change the correct answer to B. So if B is larger than A, then the correct answer is B, which will be right here. And last but not least, if A is not larger than B and B is not larger than A, therefore they're equal, so the correct answer will be C, which will represent the equal symbol. Once we have the correct answers section set up, let's go ahead and create a comment. We're going to put that, we're going to attach it to that first if else block in this nested if else section. And let's go ahead and put sets the correct answer. All right, so that sets the correct answer. Now things are going to be a little more complex because we have a gigantic block of code here. And it's going to be really important to stay organized. We want to tell the user to enter in a correct answer. I'm going to put the say block right there. I'm going to double click. We'll tell the user which is larger. A, well, let's tell them fraction A, fraction B, or are they equal? And you know what? I'm going to use some good grammar right here. I'm going to get rid of that question mark and put in a colon there. All right, so once we get through with calculating the output A and output B with the random numbers, making sure that it's a real number, not something that has 0 in the denominator, then we'll come down here and set the correct answer. Let's go ahead and run it real quick. And it should run through the code. And we'll look over here for the correct answer, seeing if A is greater than B. Sorry about that. I had to stop my video and check things out because my program, I was noticing, wasn't running correctly. And yours might be running correctly. Mine was doing this, and I was sitting there thinking, I was like, this is not correct. It should be going all the way down to here and executing this part of the code and setting the correct answer and stuff. But it wasn't doing that, and so I stopped the video to figure out what was taking place, and I realized I had made a little mistake when I was typing something in. And this is a good instructional moment here. Inside valid entries, you have to look real close. I typed in the word true. However, in front of the word true is a space, and you can barely see it. So I have to type in true with no space to make sure that it gets entered in correctly. And then when I run my program, everything gets calculated, and we move into the save block, which was down below. Now, just for controlling purposes, I went ahead and add the next step just because I was testing that. I was beating myself up over here trying to figure out what I did wrong. I was like, man, I kind of look silly sitting there. Saying I'm sitting here teaching you all this, and I got an error in my code. Okay, it can happen to anybody. Anyhow, down here, I added this new block of code called the wait until. And inside wait until, you can go ahead and do this as well. There's a nested Boolean blocks. And let me go ahead and pull it, or operational blocks, if you will, or operator blocks as Scratch calls it. Okay, there's 2 of them right here. I took my player answer, placed inside the equals, I put it to 0, and then I took the equals and I put in the not. And what we're saying is, if this is not true, then we'll count it as true. So in other words, if we're waiting for the code to have player answers not equal 0. So when player answer does not equal 0, then we will move forward. And we're going to control that by putting it until the wait until block. So this code will wait until player answer does not equal 0. When it does not equal 0, we will move forward. That means the user is going to have to enter in information. And they'll be able to enter information by clicking on the A, the B, or the equal symbol up here. Next, we want to go ahead and set up some code so that our user will get points if they do get the answer correct. We're going to put in a if-else block. I'm going to try to put in an if-else block. I'm going to put it right there. We're still inside that major repeat until block. And inside here we have Boolean options. We want to get the operators, and we want the equal block, and we want to go ahead and see if the player answer is equal to the correct answer. So if the player answer is equal to the correct answer, then we're going to change the score. Let's go ahead and get change. Put it right there. Look for the score variable. We're going to change it by a +1, and we're going to give them a happy little message for about 2 seconds. Let's say, yay, you are correct. And I'm going to go ahead and make that capital Y for yay. So yay, you are correct. If they get it correct, then we give them a +1 to their score. Below that, however, is the else section. So if this is not true, they do not click on the correct answer, we want to deduct a point and give them another message. So I'm going to go ahead and right click on change score, choose duplicate, and drag it right down there like that. And let's change score by -1. We're going to take a point away from them. And let's be nice and say you are incorrect. You could tell them something funny if you want to, like, hey, try figuring that again or something, you know. I guess that's not very funny at all, is it? But I'm sure you will think of something very funny with you and your friends. Over here on the sensing, we're going to ask the user, by using this ask block to enter in information to see if they want to keep playing the game. Now, a lot of people get confused with the say block. Right here, we're asking them a question in say. Okay, that's true. But the say block just puts information out on the screen. The ask block will ask whatever we type in here, and it'll put a blue little window over here on the stage area that will allow the user to type in information. And we want them to type in yes or no if they want to play again. Y for yes and N for no. So we'll go ahead and put that information in there, and we'll go and set the variable value, which is going to be, whoa, it should go right there. Hey, stop that. All right, so get the play again variable selected right here. There you are. And we're going to set the play again variable to what they answer. The answer to the ask block is stored in a reporter block called answer. So whenever they enter information, it gets stored inside this answer variable right here. Whoops, I didn't mean to do that. So we'll place it right there. And you can see whatever they answer to the question by clicking on this little tab, and it'll make the answer variable readout screen show up right here on the screen. I'm going to leave it up just so you can see it whenever we run the code. You can check it out. Whenever you make your program ready to give to your friends to go out there and see if they can get some fraction questions correct, you can go ahead and turn that off. And we'll actually turn off quite a bit of these because we don't want to create a bunch of noise on the screen that's going to distract the users of our program. So whenever they ask this question, the user enters information, and the information gets stored in the play again variable. Last but not least, if they answer N for no, that means the program will stop. If they answer in Y for yes, they'd like to play again, this variable right up here at the very top in the repeat until will allow the program to keep running over and over again. Because remember, it's going to keep repeating until they put an N for no in the play again variable, which is set right down here at the very bottom. If they do choose N, we're going to give them a message, let them know their score. We're going to get a join operators. These are pretty cool. This is actually performing a pretty complex programming concept called concatenation. So concatenation means you're joining in different values, almost kind of like you're gluing them together. In our case, we're concatenating a string entry with a variable. Let's say, thanks for playing. Your score is, put a space, then come over here to data, grab a score block and stick it right there. And now we're close to being done. So if we click on the green flag, we'll go through, calculate our answers. We'll get to choose A or B. And you'll notice nothing happens. That's because we have not programmed these yet, okay? So we have to get these set up to work. Let's go ahead and do that next. Before we finish this program out, let's clean a little bit of this mess up here. We got these data output boxes everywhere. It's kind of becoming a mess. Before you clean it up, let's make sure you have some valid entries coming in. Just make sure you're on the same page here. You should have numerators A and B and denominators A and B in a range of 1 to 10 based upon these random numbers over here. And you should have output A and output B coming to some sort of number with a decimal value, so that way we can compare them. Your correct answer should be getting selected properly from this line of code down here. We also should have valid entries set to true, and score in round 1 and play again should all be set to their proper values. Player 0 should be 0 because that's what we chose from the beginning. Okay, so make sure you have all that valid. Everything looks kind of similar to what I have on the screen. Let's get rid of some of these values. Let's get rid of play again, and let's leave round up there so we know the round number. Let's leave score. Player answer, let's leave that up there so we make sure we have the right information. Output A and output B. Let's put these down here just so we can cheat. No, we don't have to think very much. Valid entries, mine was working pretty good. That won't serve much of any purpose in the future, so I'm going to get rid of that. Numerators A, B, and denominators A and B. I'm going to go ahead and set these fractions up here. So numerator A and denominator A goes right there. And denominator B over here. And our good friend numerator B right there. And last but not least, our correct answer. Let's leave it right down here. So that way we can validate that the correct answer and the outputs all match up. Let's go over here to A block. We want to choose an event block called when this sprite is clicked. We're going to get our set block, and we're going to set player answer, and make sure you don't do anything silly like I did and put a space in there. So when this sprite is clicked, it should set the player answer to A. If you want to, you can go ahead and click on A right now and see if that happens. And it says you are correct. Okay, so player answer gets set to A. Now don't worry about this automatically starting. It's just doing that because of the way the code is set up inside our program. No big deal. Let's go ahead and go to the B block and let's do the same thing. Actually, I'm going to copy this over. I'm just going to drag, drop it. Then it automatically appears here. Change it to a capital B. And when we double click on B, it should also set the player answer to B as well right up here. And last but not least, the equal block. Let's go ahead and drag and drop it right there. And let's change this to C. The probability of you having an equal or two fractions equaling each other is very, very low, but it's still worth having there as an option. So let's go ahead and run our program. Round one, which fraction is larger, A or B? Are they equal? I'm going to go ahead and choose B. I knew that's incorrect, just for the record. Okay, should have subtracted one from the score. We're going to another round. I'm going to type in lowercase y for yes, just to show you that it will work. When you do more advanced programs like Java and C# and C++ and all that good stuff, it won't work in there. Okay, so you need to watch out. Scratch could be building a bad habit by letting you think that you can put lowercase and uppercase letters in place of each other. Let's go ahead and choose B because it is correct. Oh, it's incorrect. Wait a minute. Let's check that real quick. Okay, I'm going crazy here. I knew I got the right answer last time. Okay, what happened was I have equiblock set to B when in reality that should be C, and B block should be B. I feel pretty silly right now. Okay, so I apologize if I confused any of you out there, but you can see that happens to anybody, and when you're trying to record these videos and talk your way through the code, it gets a little bit cumbersome. So go ahead and test your code out, make sure everything's working properly. You should be able to see that the correct answer is down here, and then when you click on A or B or the equal block, it should give you the player answer that matches with it. I'm going to go ahead and pick, let's see, let's go ahead and pick A, just so we know it's correct. We'll put in Y to repeat it. Round two, are they equal? Let's go ahead and put in A, so that way we know it's incorrect. And okay, it looks like we're good. Let's go ahead and test out the B one real quick. Okay, so B should be incorrect this time. Yes. Okay, so I think it's got it. I think we worked out the bugs there. All right, now let's think about this. How can we repeat this for more than one round so that way we don't have to keep answering yes or no every time the program runs? We want the program to keep repeating. Now, I haven't done this on this particular program, so I never thought about it until I just said them at the video section right there we just finished. But let's go ahead and figure that out together here. Let's go ahead and click on Control, and we want to repeat, because I know I want to repeat a part of the code, and let's set it for 5. Okay, we can set it to whatever value we want. And I'm guessing right here, since the repeat until is going to keep repeating until play again set to no, that means we want everything inside of it to keep running. However, we don't want to keep asking over and over again if we want the user to keep playing. So what I'm going to do is I'm going to drag this out of there. I'm going to put it on to the side, and we'll put it back in a second. And I'm thinking if I put the repeat block right here, notice how that white line appears in between the broadcast and the repeat until block right there. I'm going to drop it right there, and everything inside this should have been put inside the repeat block. So if you follow the lines here, repeat is on the second level of that nesting. You go all the way down to the bottom, and there it is. Okay, so everything got put inside that repeat. So when we run the code, it's going to keep repeating everything inside here until play again is equal to no. And it won't get set until this code gets added back. However, we want it to run the game 5 times. I'm going to put this right here. I know it goes right there because the repeat until was on the outside shell of this nested block of code with all the repeat and repeat until blocks. I knew it was on the outside, so I was able to just go ahead and understand that I needed to put it right there. Okay, you'll be able to know where that is just based upon the layering of all these different nested blocks. It can get a little bit tricky trying to keep up with the lines, but if you just take your time, you'll be able to see them. And let's go ahead and run the program here. So round 1, correct answer. I'm just going to click on anything. You are correct. Round 2. You are incorrect. All right, I'm just trying to get through this. And round 4. All right, you are incorrect. Last round, round 5. Should stop after this, unless I forgot to do something. You are incorrect, and there it goes. Ask me if I want to play again. I'm going to choose no, because I've embarrassed myself with getting a -3 on the fraction test. Okay, so there you have it. That's how you put the program together. There's a little bit on how to expand it. You can actually do a lot more with this than just repeating the fractions. You can add in sound, animations. I'll kind of let you play around with it and figure out different ways to make this work. Also, just so you know, whenever I was clicking on the B, it automatically causes the sprite you're clicking on to have its information showed right here. If you click on the widescreen view and click on the play button or the green flag, it won't do that because everything will be locked into place right here. And last but not least, let's go ahead and stop this. We are going to go ahead and get rid of some variable windows so that way we can make this a little bit more deployable and friendly if we want to test out our review skills for math. So player answers, I'm going to remove that and remove correct answer. They don't need to see the correct answer unless you want to cheat. Output A and output B, we don't need that right now. Numerator B and denominator B, I'm going to right click on that, choose large readout. So now it's a large number. Now I'll do the same thing with that. Okay. Large readout. That's it. Let's click on the wrong one. Okay, so that way they appear right there. Same thing with numerator A and denominator A. So that way it shows like that. And it looks a little bit more like a fraction instead of having the kind of the long variable name with the data on the end of it. All right, thanks for watching the videos. Hope you had a good time. Go out there, practice some more with this stuff. Make sure you subscribe so I can give you copies of all the different materials that go with this particular lesson. Keep coding, and we'll see you next time.